Finally come. Alright, let's see what we got. Why so jialat one? Why so dirty? What's wrong? Time to send a complaint already. This Sam Go shipping my first time I hear other people buy from them quite good but then quite jialat
Absolutely yes. I think first impressions do matter. Faster shipping means happier customers.
Wait, but that's going to raise costs. We are talking premium logistics for new customers who might not even come back.
And from my side, our warehouses are already packed. Priority shipping could throw our schedule off completely.
Come on, we can't put our numbers on goodwill.
We also can't run on feelings.
So what do? Roll it out? Hold it back?
Guys. Maybe it's time to let the data do the talking.
Hi, we are Group 4. Our team members are Brian, Jovan, Ishan, Sui Huan, Kane, and me, Hui Xin. Today we are presenting about Samgu shipping. Here's the problem we are addressing. Samgu noticed that first-time buyers tend to return products more often than repeat customers. Since returns are costly, we want to find ways to reduce that. Specifically, our focus is on whether upgrading first-time buyers to priority shipping can lower return rates by 2 percentage points, and if the reduction is enough to justify the extra shipping cost.
So behold 1,000 rows of life choices. Each time is a first-time buyer deciding whether to love or hate their purchase back to us. Yes, Central Limit Theorem fans, there are 1,000 of them. So this is the opening the fridge at 2 AM step. We read the Excel file. We get 2 key ingredients, shipping method, standard or priority. So outcome is 1 if they returned it, and 0 if their inner influencer says keep it. So the goal is do faster packages equal fewer breakups. So we split the work into 2 tribes, standard and priority. Then count how many orders and how many it's not you, it's me returns in each. The rate is just the mean return. So statistics way of saying what fraction regretted this purchase. So here's the vibe check. Priority has more orders, so clearly our customers love speed. Return rates, they are suspiciously similar. In other words, faster shipping might deliver joy, or it just delivers the return label sooner. So we put 4 numbers, the return rates for standard and priority, and how many orders were in each group. So these are the inputs to our comparison. So our metric is D equals to P priority minus P standard. So the interpretation is if the priority has a lower return rate, then that's better. So you can read D as how many percentage points better is priority at reducing returns. So the business threshold is practical. We need priority to reduce returns by at least 2 percentage points to justify the cost. So H dot says it doesn't clear that bar, and H1 says it does. So which test do we use for the hypothesis test? The outcome is binary, so it's either 0 or 1. We are comparing 2 proportions return rates, not 2 numerical means. So for large samples by CLT, we can approximate the sample to be normal. So because we have large sample size in both groups, so the normal approximation is valid. So a t-test is for comparing means of continuous variables. So that's not our situation, therefore we use the one-sided t-test. So this is the calculations, and we found that alpha is, we set alpha to be 0.05 and the z critical we found to be minus 1.645. Okay. So at alpha 0.05, we get z equals to 0.45, which is, and the p-value to be 0.674. So that means our sample doesn't show a large enough improvement to meet the 2-point target. So therefore, we do not reject the null hypothesis. So in conclusion, we do not reject the null hypothesis. We do not have sufficient evidence that priority shipping reduces returns by the required 2 percentage points. So based on returns alone, we would not recommend paying to upgrade or first-time buyers to priority shipping.
So now we'll be talking about how our statistics can help us to enable our existing problem statement. So here we are quantifying financial impact. We're not using statistics just to test a theory, we're using it as a decision-making skills. By analyzing data, we check whether priority shipping actually have lowest return rates enough to save money on refunds, restocking, and logistics. This goes beyond just operational visibility as it quantifies the financial impact of the initiative. Based on our results, statistics here acts as a decision tool helping Zengo to decide if investing in faster shipping makes financial sense instead of relying on assumptions.
So our second reason for statistical analysis is for use as a governance tool. So statistics gives us a common language whereby there is a shared objective standard that aligns operations, finance, and customer experience all under one rulebook. So instead of relying on opinions or gut feel, we make decisions based on data. So for example, our 2% improvement rule becomes like a clear decision point whereby if the performance improves by at least 2%, we move forward with the plan. Otherwise, we do not follow through with the plan. So this is simple, transparent, and consistent. In summary, this approach also ensures governance across all teams. So everyone follows the same standard and every decision can be explained and defended. The 2% threshold thus becomes a decision rule that everybody agrees on, making rule of decisions transparent, fair, and repeatable.
The third reason is data-driven rollout decisions. Instead of viewing this as merely a statistical test, the 2% target functions as a performance benchmark, guiding whether Samgo is ready to roll out priority shipping option. This helps us as this statistical test acts as our gate. If the data shows that the target is met, we scale the rollout, and if not, we hold back until it's proven effective. It enables us for smarter operations as it ensures that expansions are data-driven and not assumption-driven.